Hi, in this video, I'm going to talk about OSPFv2 operations, specifically OSPF packet types and establishing adjacencies. So these are the OSPFv2 packet types: hello, database description packets, link state request, link state updates, and link state acknowledgements. We'll talk more about those in a moment. Okay, so these are kind of we can see that the hellos are used actually to establish neighbor adjacencies. And then we're going to see that these other ones, the database description, which is an abbreviated list of the sending router's link state database, kind of a summary. We have a link state request, which is used by a router that says, oh, I got your summary, but you know what? I need more detailed information from you. That's known as a link state request. A link state update, which is actually the link state information. And a link state acknowledgement, which is used to confirm the receipt of another OSPF message. Not hellos, but the DVDs, LSRs, and LSUs. Okay, so we said that there's 5 types of OSPF version 2 packet types. Link state updates are used by the routers to synchronize their link state databases. And basically, this is how they build their link state database. From that, they run the SPF algorithm. From that, they get their SPF tree. And from that, they determine what the best path is to every network. And from that, they offer the best path to the routing table. Okay, so for these link state updates, we'll see this in later videos, but there are several different types of LS link state updates. We call these LSAs, link state advertisements. A lot of times the terms LSU and LSA are used interchangeably. Okay, establishing adjacencies. So before an OSPF router can flood its link states, as we saw in the link state operations, first it needs to know who are my neighbors? Do I have any neighbors on my links? Okay. And it does that using hello packets, and we'll see that in a moment. But before 2 routers can form this neighbor adjacency with another router, and they do this through hellos, they have to agree on certain things with those neighbors. Hello interval, the dead interval, and what network type we share. We'll be talking more about these. MTU, maximum transmission unit, must be the same also on both ends. It's not a requirement as far as OSPF informing neighbor adjacencies, but the routers will be stuck in what's in the DBD, database description exchange. So, but we'll focus on the other 3 here in a moment. Also, both interfaces must be part of the same network or subnet. They must have the same subnet mask. Okay, hello intervals. So by default, OSPF sends hello packets, OSPF hello packets are sent every 10 seconds on multi-access and point-to-point segments. They're sent every 30 seconds on what we call non-broadcast multi-access segments. These are like frame relay, X25, ATM, not so much of that used so much anymore. Okay, it's sent to a multicast address, all SPF routers. So if you're running OSPF, you've got to listen and process for these. And it's sent at 224005 or FF02:5 for IPv6. We'll see that in IPv6, OSPFv3 later. Okay, the dead interval. The dead interval, also expressed in seconds, is how long will this router wait if it doesn't get a hello packet from the neighbor before declaring that neighbor down. So Cisco iOS uses a default of 4 times the hello interval. So that would be 40 seconds on multi-access and point-to-point segments, 120 seconds on those NBMA networks. So when the dead interval expires, OSPF removes that neighbor from its link state database, floods that link state information to its neighbor saying, hey, this has changed. And of course, it's going to have to rerun the SPF algorithm, come up with a new SPF tree, and then offer or remove routes from the routing table. Okay, so that's just a brief overview of OSPF operations, packet types, and establishing adjacencies. More on the operations in the next video.